about, I am recording. Say hello. Let's talk about the transformations real quick. All right. So let's say we know what this looks like. Okay? We can figure it out pretty quickly. All right. So now I'm going to transform. I'm going to do this. And I'm going to do I don't want to do that. Okay. All right. So those are two transformations. Could do one more, I guess. All right. Be careful. The first and the third are different. Thus, if this wasn't here, this would also be written as. Be careful that one is not necessarily in the parentheses like this.
That was one of the.
Right. Okay. So once we know what this looks like, what should happen with this transformation? One to the right, just like when we were doing a quadratic. If it was inside, we'd move it to the right. If it was outside, like this one, we'd move it down, up or down. Okay, so this is outside of the logarithm. This is inside of the logarithm, outside. All right, and this is a stretch, right? We're going to stretch our y's by 2, times them by 2. Okay. All right, so what does the basic y equals log base 3 of x look like? So we don't know what we're transforming if we don't know what the first one. Plug in. I know this is new stuff, so you plug in just like when you were in what? 6th grade, you were plugging in points to get those lines, and now we do the slope and the intercept, so you're just learning. We're plugging a 0, of course. No, we don't, because we don't know what 0 is. All right. I guess since I could plug in a 3 here, I could plug in a 9. What else could I plug in? A 1? Okay, I'm plugging in for x. All right, because that's usually what I do. Log base 3 of 3. What is that? 1. That's 1 because 3 to the first power equals 3. Okay, so I have 3, 1. 1, 2, 3, 1 right here. Okay. Log base 3 of 9 is what? 2 because 3 squared equals 9. Okay, if you're not there yet, you're not able to do that really quickly. You'll get there. That's my grand plan, but 5, 6, 7, 8, 9, 2. Okay, we probably know what it looks like now, hopefully, because you've had that much experience. What's log base 3 of 1? 0. 1, 0. Okay, so it's supposed to go like this. Okay. It's an exponential flipped around the y equals x. Okay, so now we're going to take this. I'll just color code them. Right here, we're going to take this and move it 1 to the right. So this is going to move to the right. This is going to move to the right. This is going to move to the right. Now we have a new equation. Okay? So you got to check order pairs. You have to be, if you use your calculator, you're not using your transformation properties. Okay. Now here, we need to multiply all those things right here by 2. Okay, so 0 times 2 is still 0. This was 2 times 2 is now 4. And this is 1 times 2. Wait. That was 2. Anyway. Okay, it's up here. All right, so then we go like this. Okay, so we should have taken 2, 4, and 0. Okay, 3, 2, 2, 2, 2, 2, 2, 2. Okay. All right, one more. I need a color, purple. All right. I'm going to do purple with this one, and remember we said we are supposed to go down 1. So we go down 1, down 1, down 1. And there we have the new transformation. That's really bad. Okay. All right. So, yeah, it's going to be a little bit more trouble to transform because of your lack of experience in logarithms, just in general graphs. Okay. So I would take some time to know that what your logs look like. Okay. And then you can transform them from there. Right? Okay. Anybody have any questions homework-wise or otherwise here? Negative log and negative x. Okay, let's see. Let's go for color orange. Okay, so you're talking, that looks a lot like red. You're talking this, or she's also talking this. Okay. So what do you think happened? This is the same, basically this is the same as this, except instead of stretching, we're multiplying by -1. So you could do that. So again, our originals were here, here, and here. So if we multiply by -1, that's going to put that here. 0 times -1 is still 0. I lost my orange pen here. All right, and then that was what, 1? So that would go this way. And then that was 2, so that would go this way. So it kind of goes like this, like this. Yes, that's what I would do. All right, and then this one, remember, you have to figure out, I'm not going to go crazy on these transformations, so if you don't really want to worry about that, don't, because I'm not really going to go crazy on these transformations. You know, I'm going to do moving right or left, I'm going to do stretching and compressing, but that's all I'm going to do.
We'll be like the 2 transformations.
Yeah. It's actually a section that I give you this, and you have to match up the graphs. They're not all there, but like I would give you a set. Yes.
So if this, you can
But-
always put like a table.
Yes, absolutely. You could always do a table. Yeah.
I just find the original very confusing.
I agree.
have
I agree.
flips.
And remember how long you plugged in points with linear equations. You did that for years before you're like, wait, there's an easier way to do this. Let's do slope intercept. Okay, so that's where you are with logs. Plug it in points. Totally okay. All right. All right. So let's. Anything else on homework before we leave the homework? All right. I have a question. All right. You have 2 kinds of exponential equations. All right. We had something like this. 2 to the negative x plus 3 equals 32. And we had 2 to the negative x plus 3 equals, we're not even probably ready to do that one yet, equals 5. Okay. All right, now this was 5-3. We did this in 5-3. And we did a few of those in 5-4. We're going to do some more now. What is the difference between those? It's huge. One you're going to use logarithms to solve, the other one you aren't. Which one are we going to use logarithms to solve? That one is right. And how do you know that, Francis? Well, how do you know you don't have to use it there?
Because
It is a power of 2. Okay. All right. No logs required. And here's the problem when you get to the test.
They're all mixed up and you're like, wait, I don't need logs, I need logs.
So you've got to figure out, the first thing you should check is, could they be written as the same base? Okay, so 2 to the negative x plus 3, 2 to the 5th. Okay, because if that's the case, that's so easy to solve. We just drop the powers because we know that, so we drop the bases, sorry, because we know the powers have to be the same if the bases are the same. And it's a simple little thing to solve. Okay, now this one, not so easy. So you got to be careful. If it's simple, do it simple. You can do this the log way, but why if you don't have to? Okay. All right. So this is the first thing you need to ask yourself: could it be written as the same base? Now we could change them both. Okay. So you think you're ready? Sorry, negative. Yeah. Sorry. Thank you. Okay. All right, let's try this other one. I'm going to try it. 2 to the negative x plus 3 equals 5. We already said we need a log to solve it. So, is it ready to put in log notation right now?
Yes.
Yes. Okay. Let's do it. Sarah Cole.
Okay. Log base 2, and then 5.
So we say that log base 2 of 5.
Okay. Equals negative x.
Okay. All right. I'm solving. I'm trying to figure out what x is. Okay. So I need x by itself. So Ella, what should I do now? Good. Log base 2 of 5. Subtract 3. Now the 5 is the only log piece. The 3 has nothing to do with the log. Whatever you get for the log base 2 of 5, then you subtract 3 from it and you get negative x. And then, okay, or divide by negative 1, either way, equals x. Yes, geez, I have 1,000 here. Thank you. No, you're good. I'm really okay being corrected. Okay, very good. So that's your answer. It's not pretty, but could anybody estimate without plugging in your calculator what maybe the log base 2 of 5 is? Okay, it's certainly over 2, because 2 squared is 4. 2 to the 3rd is 8, so it's somewhere in between 2 and 3, so she's guessed at 2.3. Very good guess. Okay? I mean, you can figure it out easy enough, but if you can do that, you have a good grasp of what logs are. If you're like, what? How did she get that? Then you got some work to do. Okay, which, I certainly expect. All right, let's talk about logs some more, shall we? I want to put this here because otherwise I forget to turn it off. And it goes forever. Okay, so we're going to talk about properties of logarithms. Honestly, these are like, is this your first page? I think I switched them up. I didn't know I was switching them up. I didn't mean to. Is it this one?
I think actually, it's a way, I think also, you added logs reading. Yeah.
Oh, well, good. Okay, how's that? You like my little logarithm guy?
Did I draw that? Do you know me, Ruby? I do not draw.
I'm not freaking drawing. Okay. I'm not supposed to say that, but it's true. All right, so M and A are positive real numbers, okay? That's just by definition. A is not 1 because A is our base. And remember, 1 to any power is 1, so it's like stupid. And R is any real number. So R can be negative, can be irrational, can be just goofy as heck. Okay, so this is a property. If log base A of 1 equals 0, any base Why would that be?
Because anything to the 0 power.
Anything to the 0 power is 1. It's just a quick switch. So, why am I telling you this is a property when you could figure it out? Well, because you could do it first. If this is 2, any base okay, they're all 0. Okay, even ln is 0, because remember that's base E. Okay, so that's 0. That's the first property. Again, you can figure it out by doing, but I'm trying to save you some time. If you know the properties, you will get there quickly. Okay, here's the next property. Log base A of A is 1. Well, duh, because why? A to the first power is the same as A. So let's look at some examples here. Log base 2 of 2. What's that? 1. These two have to match. Log base 10 of 10. Log base 5 of 5. Okay, so that's that property.
You could do that on too.
Yes. ln of E is 1. Remember the base E is 2. Okay, good job.
It was the log base 1 of 1.
What? This can't be a base.
Okay.
Okay.
It would be either 0 or 1.
Yeah.
No way.
Yeah, it's not defined technically,
Okay.
and it's 1. Okay, now this one is kind of weird. Number 3. All right, A to the log base A of M equals M. Okay, this is what form, log or exponential? Exponential. So let's switch it to log. Because log, what's my base? A, right here's my base. What's my exponent? Log base A of M. Wait, sorry. Nah. So that goes here, equals log base A of M. Duh! Log base A of M equals log base A of M. So when you put it like that, but it's really weird to do that, isn't it?
Yeah.
This is exponential. Here's your base. Here's your exponent. So that's your log over here. And then there's the other number. Remember, there's always 3 numbers that you got to match up spaces. Okay, so give me an example of this, but not with A's and M's. Give me some numbers in there. Somebody? 3 examples.
Log 2.
Base 2.
Base 2 of 3.
Nice. Okay. So essentially, when you take 2 to a log base 2 power, that kind of cancels itself out. This one is super nice to recognize because it's just weird if you don't. Okay. Let me give you another one. Now I'm going to trick you here. 4 log base 2 of negative 3. The trick. Go for it. For me. Oh, sorry. I didn't mean to even do that. Huh. No. That was not even my trick. I tricked myself. There you go. There you go. There's the trick. Oh, so what does that mean? Okay, so it does not exist, right? Good job. Okay? I can't tell you how many people fall for that one and you tell me it's negative 3. Remember, this number right here cannot be negative. So remember, it's still fitting the rule, but because it doesn't exist, because that really can't happen. Okay. Anyway, the next one, number 4, log base A of A to the R equals R. All right, again, this is what form, log or exponential? Log. So let's go to exponential form. My base is A. My exponent is my log, so the log is R equals the other number. Again, duh, AZR equals AZR, okay? So again, that one's nice to remember if you recognize it. Let's see, for examples, how about log base 4 of 2 to the 4th is what? Let me get some good numbers in here. 4, oh wait.
That's not.
Jeez. Let me try this again. Log base 4 of 4 to the 2nd. How's that?
Okay.
Equal to 2. Right. All those 4 kind of cancel out each other as long as they match. Log base 12 of 12 to the negative 2nd. It does exist. They'll pull out because this is a fraction. It's not a negative number. It's 12 to the negative 2 is 1 over 12 squared. 1 over 144. Okay? Correct. Correct. All right. Let's see. You'll keep track of it because you'll have lots of practice. Is this your next page?
Yes.
All right. Now, this, remember what a logarithm was? A logarithm is an exponent. We got to keep reminding ourselves that that is the case. When you are multiplying x to the 2nd times x to the 3rd, what do you get? X to the 5th. You're adding the exponents, right? Okay, so when you're multiplying m times n, two numbers with the logs, then you're really adding the logs because you're really doing that, right? Because that's what logarithm is, an exponent. All right, so let's give you an example. Log, and the directions are such that you're rewriting products as sums, quotients, differences, powers as factors. Okay. I'll go through an example, but this is what it looks like. Log base 2 of 8 times x. Okay. Would equal what? What would that equal? Log base 2 of 8 plus log base 2 of x. Now, what's log base 2 of 8? 3. So 3 plus log base 2 of x. Okay, if you can simplify, then you should. Okay? But this is the property that we're working on right there. Log base 2 of x, 8x. Okay. Log base 6 of x, y, z equals. All right. Take it, Sarah. Call up.
So, okay, log base 6 of x plus log base 6 of y, and then log base 6.
And then, what does that mean?
Oh, sorry.
Okay. Plus log base 6 of z. Perfect. Good job. Okay? So if you have 3 things multiplied, then you just add 3 things. All right? What if 2 of those things were the same? We'll come back to that. Let me erase this right here. All right. What do you do when you x to the 6 over x squared? What do you do now? What does that equal? X to the 4th. So you take and subtract, right? Okay, so that's the second rule. Because logarithms are exponents, when we're dividing a number and taking the log of it, we're really subtracting the logarithms of each. Okay? So log base 2 of 8 over x. Okay, well, how would that be rewritten as a difference? Francis?
Base 2 of 8 minus log base 2.
Right, and then log base 2 of 8 is 3 again, so we get that. You don't know what the x is, so you're not solving for x, you're just rewriting, you okay? All right, okay. Let's do one more. Log base, and a lot of times these are kind of contrived, but we'll get to a point where we'll need to use the logarithms, but when we get used to them, we're just kind of making stuff up, really. All right, let's do 5x over y. All right, we got 2 things going on here. Three things going on. Yes, that is base 5. Yep. All right, anybody want to take a shot at it here? Go ahead, Emily.
Log base 5 of 5 plus log base 5 of x. And then that whole quantity is minus log base 5 of 5.
I was just going to say that. Good job, Emily. Okay, 5 and x is multiplication, so we should add those. And then we're dividing by that, so we have to subtract that. Good job, Emily. And again, like she said, technically, it's not going to matter if we have, yep. But honestly, that was perfect. I like that you said the parentheses because you're really multiplying. Remember, when you do that in that order, it's really okay, left to right, so you're good. And yeah, this would become this. Okay, good job. All right, the last one on this page is this piece where it says the powers are factors. All right.
Because of
Yes, let's talk about, let me just give you one. Let's say we have log base 2 of 2 to the 3rd. Okay, I'm going to rewrite that so we can use our, sorry, I don't really want to do that because I don't want to use that other property, so I don't want those two to match. Because log base 2 of 2 cubed should have been what? 3 from the property on the other page. Okay, so I don't want these to match. That's on purpose. Okay. 4 to the 3rd is 4 times 4 times 4, right? All right, so that means log base 2 of 4 plus log base 2 of 4 plus log base 2 of 4. It also means 3 times log base 2 of 4, right? Because it's 3 things of the same. And what is log base 2 of 4? What is log base 2 of 4? 2. So this should be 6. Okay, that's a long way around. Now let me show you the, did I lose anybody on the process? I went through it pretty quickly. But I changed the power to a multiplication. And then I used the addition, adding the logs because I'm multiplying them up here. All right, I'm going to give you a shortcut. That is rule 3. Log base a of m to the r equals r log base a of m. So if I had this problem, log base 2 of 4 to the 3rd, this 3 comes out front, because that's what it does. There's my 3 times log base 2 of 4. Okay? And remember, that was how many steps in right there. Log base 2 of 4 is still 2, and we still get 6. Okay? We're going to do some simplifying. Let's try another one. Let's see. This, there's nothing wrong with that. It just takes a longer time. Okay? Because we were right here 3 steps in. All right. How about log base 3 of 27 to the -1 power. Okay, go ahead and try to evaluate that using your powers or your whatevers. You done logarithms, Helena? No.
The only thing about those was the completely different.
Okay. All right, what'd you get, Sophie? Renee, sorry. -3? Yes? So the first thing you did was pull this around and did this? Is that the first thing you did?
Yeah.
Good job. And then you said that is 3 because 3 to the third is 27. Perfect. Good job.
Okay. I just did -1 times 3. Is that wrong?
I did -1 times 3.
Okay.
Yeah, you're good. You just were a step ahead of me. Yeah, because this piece is 3 right here. This is 3. Did you recognize that?
Recognize if I just took 1
Say that again.
So like, you know, there's like a -1 and a 3.
Uh-huh.
So I just took that out. I feel like
No, you can't do that. That's just coincidental. Did anybody do this? Log base 3 of 1/27 and change that like that? You could have. Why? Yeah, that's, sometimes you do things and then you're like, why did I do that? But, you know, and then you could say, all right, I know 3 to some power is 127. I know 3 to some power is 3 to the -3rd. Well, then x clearly is -3. It's a roundabout way, but it still gets the same answer for -3. Yeah, you just got lucky there, I think. Let's try one more. And then we've got a few more. All right, I'm going to mix up all the 3 on this page. So we're going to rewrite as a sum or difference. And also says write roots, sorry, factors, powers as factors. That's basically the directions. Okay, it may be more pretty than that, but okay, so I'm going to do it with just letters so that we don't have to do any simplifying when we're done. We're just going to rewrite. Okay, so let's say we want log base 2 of x to the second y all over m. Okay, so we got a lot of stuff going on. I'm trying to clean up my parentheses here a little bit. All right, so rewrite that. This maybe? Okay, and then this is a power, you write it as a factor. A factor, remember, it's multiplied now instead of to a power. That's what that means. And that's what they will tell you. And then I got what we got. I don't know why I'm rewriting that, but good job, Ruby. Okay? So, what about, I said that was one, let's try different. What about log base 2 of xy squared? How would you rewrite that? Same directions, rewrite as sum or difference, and powers as factors. The first thing you probably should have done is done this. Try not to get too far ahead, and then this.
I realize.
And you do not have to distribute it, no. Most of you, I saw this. And I'm guessing that you went here, you did, how did you do that? So did you do this first?
Yeah.
Okay.
I just knew
Okay. Right. These are, I would take either of these answers. I don't care.
I like to get rid of these if it doesn't make it too complicated.
That's probably good plan, honestly. Yeah. So you factor.
Yeah.
Okay. All right. One. Let's try these. I think we're probably want to give them a whirl here, and then we'll talk about them. Do it. Because I've been giving you examples, so try those, and then I'll do the same, and then we'll talk about them. Try to use your properties. They're all very easy if you know properties. But the problem is you've got lots of properties going on. Oh, man, go for it. I conduct other business in our class, shall we, Miss Natalie? Why would you do that? You need to. You're here. All right. Okay, ready? So what does this one equal? 18. What property is that? So on the first page, hello, where are you? Here we go. Which property? 1, 2, 3, or 4? 3? Okay. All right. Sure it is. Yes, it is, but the answer is not -5. It does not exist because of the negative, what do we call that again? Argument. Okay. All right, otherwise it would be -5. All right, what about that one? 20. And what property is that? Number 4, yep. All these match, so those have to be the same. Okay, and you can figure it out. Sorry, I don't know why I'm doing this. With, you know, I wouldn't expect you to know what property that is, but what about this one? And those two are the same property, right? It's just a ln e to the third is exactly like that, except there's right. No, I do not care. I told you, some people want this E here, some people do not. So it is the personal preference. I don't like it. It's distracting to me, but I get why some of you all would want to write it. Yes, go ahead. Okay. That is weird. Okay, so this we're just finding the value of. Now some of you will do this and go that, and then you're solving for x, but that's not what's there. And that's fine if you want to do that, but just to differentiate, we are now solving. If you look at this, first of all, you notice that they're both taking the log base A of both sides. Okay, taking the log of both sides is like taking the square root of both sides, or subtracting 5 from both sides, or squaring both sides. So it's a function. So they cancel each other out, or depending on which way you go, you could start with this and get this. I just went with log base 10. You'll see what I did?
Yeah.
Okay, now that's probably not what you would do. All right, but now we pull this around. And how do we get log base 2 out of it times x? 5, okay. No. Okay, we haven't gone there yet, but anyway, what would you have done yesterday to solve that? You would have changed it to log base 2 of 5 equals x. These are actually equivalent. Okay? You don't believe me?
I believe it, I don't know.
Yeah, that's why logarithms gets a little nutty because, well, that's really the same thing. So, but anyway, you put those in your calculator. This is base 10, log base 5 over log 2, and then log base 2 of 5. They're exactly the same thing. Okay. Sorry. All right, and this is the same rule except going backwards. You basically, if you have the same log base power of something and log base power the same something, that basically cancels itself off and you get m equals n. So they're the same thing, we're just going different direction. Okay? So log base 3 of x plus 2 equals log base 3 of 2. What happens to solve that? X plus 2 equals 2. So x equals 0. Okay? All right. You have to be careful on your log equations because remember, no negative arguments. So if the answer that you get gives you a negative argument, then you either did it wrong or there is not an answer to that question. No solution. Okay, so let's say log base 3 of x plus 5 equals 2. Same, oopsie. Log base 3 of 2. Okay, sorry. I'm trying to keep it with the same theme here. So x plus 5 equals 2, right? X equals, but that's not going to give me a negative argument, is it? Okay, so you're good. But you gotta check it. Yeah, but sometimes it's not that obvious. Because sometimes it could be, x squared. I think I can be done. Oh, well, huh? All right, can I put it in LMS like next block and you got it covered? Okay. Fine.